And we're ready to do notes for 5A in the Math 4 course. We will actually be continuing some of our discussions about law of sines, law of cosines. And one of the larger uses that we find with law of sines, law of cosines is in surveying. And what you're witnessing in this picture is that there is the stake at the front of the flower bed that's got a little pink flag hanging off of it. And you can see where somebody has drawn a computer red line back to the yard, back to the fence. And you very distinctly get the feeling that there's at least 2 or 3 or 4 feet of fencing that is on somebody else's property, that it shouldn't be there. And that's how surveyors make their living, is that they go around and they mark where the deeds at the county office say that the lines are supposed to go. And I had to do something like that, similar at our house here when we added on the in-laws addition. There was a statute in Johnson County that said that you had to be, I think, at least 5 feet from your property line with any building that you want to put up. And I think we had like about a foot to spare when we added on to the side of the house. But in any case, this is where, if you're looking at doing something involving the property line between you and your neighbor, especially if it's going to be something relatively permanent like a fence, you might want to consider surveying it, because I've seen too many cases where they went where they thought the line was, and then they had to spend more money to undo it. Anyway, all right. So today we're looking back at law of sines, law of cosines, and we're looking at real world problems. Now this one is a classic. This one is actually somebody trying to triangulate where a cell phone is. You see that happening all the time on crime shows like NCIS or Criminal Minds or something like that, where they have the culprit and they triangulate, they ping their phone and they get a location on them. Well, this is how they do it. There's the law of cosines involved in this, because they can tell by the signal strength how far the phone is from either of those towers. And they know how far apart the two towers are, and they're able to triangulate and figure out what is angle theta to give them an idea on where the exact location of the cell phone is. So this is an application of law of cosines in this particular case. Now let's get on to example 1. You did not have a nice pretty triangle like I did, but I figured you can draw one of your own. Now we have Egbert and we have Prunella, who are looking at a kite flying up overhead. And it says that Egbert and Prunella are standing 10 miles apart. And the angle of elevation from Egbert to the kite is 35 degrees. The angle of elevation from Prunella to the kite is 45 degrees. And so how far is the kite from Egbert? So they're looking for that length over there. Now, this is something to where if we have two angles here, so there's the possibility that we may be able to get away with law of sines on this one, because that will involve a lot less calculation. But in order to do that, we've got the 45 matched up with the x, but we don't have angle K matched up with the 10 miles. So we're going to have to figure out, well, if there's 35 and there's 45, we ought to be able to figure out what angle K is. And so when we subtract those, they add up to 80, and that leaves 100 left over for angle K. So now we've got all the pairings that we need. We can come over here and say sine of 100 matches up with 10, the way that sine of 45 matches up with x. And when we cross multiply, that times that, that times that, we get x sine 100 on this side, and we get 10 times sine 45 on the other side. Doesn't really matter which side is which. I generally We've all been taught to put the x on the left side of the equation whenever possible. It's just it's not a law, but it's a suggestion. And then we have 10 sine 45, and then we're dividing both sides by sine of 100. And so our calculator tells us this, that all of that put together is going to mean x is 7.18. I'm going to call it about 7 miles. Here we'll do as the Romans do. Everybody is in whole numbers, so we'll leave our answer as a whole number. I'll get to the end and I'll change my mind on that, but yeah, for the most part, it's a good rule to follow. All right, example 2. Tells us we have 3 boats at sea: Voyager, Escape, and Freedom. And Voyager can see E and F, and the angle between is 45 degrees. The distance from V to E is 2 miles, and the distance from V to F is 4 miles. So how far apart are E and F? Now, this is a situation where you really needed 2 angles to be able to do law of sines. So we're probably going to need to fall back on law of cosines. Now, I'm going to first of all set it up this way. Little v squared equals e squared plus f squared minus 2ef times cosine of big V. So when we plug in our players, that's actually x squared rather than v squared. Little e was the 4. Little f was the 2. Minus 2 times 4 times 2 times the cosine of 45. So we've got all of that plugged in on one side. So we should be able to put all of that together. 4 squared plus 2 squared minus 2 times 4 times 2. And that's going to give us 14 point, no, hang on. All right, it helps if I punch it in correctly. X squared is going to be about 8.686. Now, the thing that I have to keep reminding myself is that after we've gone through all of that, we're not done. That's x squared, and we want just x. We have to take the square root of that number, and we get 2.947. I'm going to call it about 3 miles. That's really, really close to that number. Okay. Next, we have a triangular playground with 3 sides and no angles. And so I'm just going to randomly assign, and just so that for the sake of argument, we'll call it A, B, and C. Now, I guess technically it doesn't matter which angle I start with. I need to pick one. So we're going to go after angle A. And then we're going to plug in our players, which we're going to get some healthy numbers on this one. Little b is going to be 401. Little c is going to be 475. And then cosine A, which is the unknown that we're looking for. Now comes the fun part. Well, 595 squared. Come on. All right. 595 squared is going to give us this beast. I'm going to add together the 401 squared and the 475 squared. So together they give me 386, 426. And then I'm going to multiply 2 times 401 times 475. And that's going to give me something looking like this, sitting on the front of cosine A. Now I'm going to have to subtract that and then divide by him. And I'll be down to cosine A. So 35,4025 divide, excuse me, not divide, subtract 386,426. I get negative 32,401. That will be divided by this negative 380 number. 389.50 leaves me with about 0.085 equals to cosine A. And when I do the second cosine, second answer, I get 85. Okay, well, 1 down, 2 to go. Now the good news is that because we have one angle, but we've got all the rest of the sides, we could feasibly do law of sines, a little bit easier math, law of sines, to find angle B. So let's try it that way. Let's do sine of 85, and 595 is across from him, and then sine of big B, and 401 is across from him. Now when I cross multiply, I get 595 sine B equals 401 sine 85. And I'm going to divide both sides by 595 to get sine B by itself. Divided by 595. And when we punch that into the calculator, we get 0.67. Is roughly 0.67. Now, the fact that it's less than 1 tells us that whatever we find out for an answer, we're going to have to check the supplement just to make sure. So when I do second sine, second answer, I get 42, and the supplement of 42 is going to be 138. So here's where I got to check both and find out if I technically have. Now I will tell you this, because you have all three sides, you're not going to have two answers. One of these is going to work, one of them is not. So let's go with green. All right, let's try the 42 first. 85 and 42 make 127, which leaves me 53 for the odd man out. Now, when I start checking angles, this is the smallest angle, and this is the smallest side. Check. This is the biggest angle, and that is the biggest side. Check. So we know that this works. We've got at least one answer that works. We know. Now, we need to check the 138 just to be sure. So when I plug in the 138 here, I can actually stop right there, because look at who's across from him. I got the smallest side across from the biggest angle. That's not going to work. We are going to go with the 42, and the 138 is too big. And we also figured that 85 plus 42 plus C is going to mean that C is 53. And we have all three angles. One more problem to go. All right, we have a post supporting supported by 2 wires. So let's say that the post is this guy right here. I got a wire on either side of it. Now, there is an 80-degree angle between those wires. Well, that didn't work out real well. All right, that is an 80-degree angle. Now, we also have a 40-degree angle with one of the wires in the ground, and we know that the two ends of the wires are 12 meters apart. So if I'm, just to give this thing labels A, B, and C, I need to find little a and little c, the length of the two wires that are supporting this post. Now, considering we have two angles, and we do have a match set, an 80 that goes with the 12, we can do law of sines. We can do the easy math. Sine of 80 over 12. And let's go after a first. Sine of big A, which is 40, over little a. Now, when I cross multiply, I get a times sine 80 on one side, and 12 times sine 40 on the other. If I want a by itself, I'm going to divide both sides by sine of 80. Well, sine 40, close, divide, sine 80, close. And I get about 7.8. Now for angle C, we are going to have to figure out, for little c, we're going to have to figure out what angle C is. So we'll come up here and we'll do this. 40 and 80 is 120. Taken away from 180 leaves us with 60. So we'll say sine of 60, and the little c that's across from it, and sine of 80, and the 12 that's across from it. So I cross multiply, I get c sine 80 equals 12 sine 60, which means that c is going to be that divided by sine 80. Twelve sine 60, close, divide, sine 80, close. I get 10.55, about 10.6. Those are my two answers. And that is the 4 examples for your notes. Your worksheets will be similar problems in that they are law of sines, law of cosines, and they are word problems.